Hi, I'm Adam Prout, CTO and co-founder of SingleStore. And today I want to talk to you about why SingleStoreDB is great for real-time applications. This is going to provide some context for some of the later talks we're going to hear today in our developer track about the latest and greatest features in SingleStore. But this talk is more about what SingleStoreDB is already very good at today. So to start off, what is a real-time application? This isn't an industry standard term. You're going to hear lots of different terms. I think they all describe a very similar use case, maybe data applications, maybe real-time analytics, maybe analytical applications. They're all going to describe use cases that have analytical query shapes, so not just simple get and sets. And yet they're going to combine those analytical query shapes with operational requirements, so low latency, high concurrency. They want it to stay online at all times. Because the analytical query is kind of feeding up through an application. So you can consider it faster, fresher, more precise analytics. To make this more concrete, here's an example real-time app. Obviously, it's a generalization. Each app might be different, but you often have data streaming into your database, in this case, SingleStore. The data that's streaming in could be from Kafka, as we show here. It could be directly from an app. The data could be IoT event data. It could be telemetry from another application. It could be market feeds from external sources. But the key thing is that the data is being streamed in as it's being generated. It's not being batch loaded. Once the data is in the database, you're going to want to serve low latency analytics from it. The analytics could be feeding in through an application. It could be feeding in through a dashboard, which is customer facing and so has kind of lower latency requirements. It could be for doing interactive analytics, so analytics at kind of human speed. And to make this more concrete, I'm going to talk about a few examples of real-time analytics in SingleStoreDB's customer base. And so this use case happens across multiple market segments. IoT is a very popular use case, a market segment for this. So a great example here is telemetry coming off of oil wells, and then doing analytics on that telemetry to detect maintenance issues early with the wells, to do profitability analysis on the wells, should we continue drilling, and day-over-day analysis of how the process is going. Another example is in telemetry coming off of cell phone towers and doing analytics on that data to detect quality of service issues early before customers detect them. Fraud analytics is another place where this happens, where you have a stream of potentially purchase information or other events that is going on in a customer account, and you want to detect if there's fraud, if there's something unusual happening on this account. You can see all these use cases kind of involve the streaming of data, and then you want to do these low latency analytical queries on that data. So now, why SingleStoreDB for real-time apps? Well, this is a use case we've been doing for a long time. So some of the earliest customers of SingleStoreDB were using us for real-time analytics, and they kind of pushed us in this direction of building a more general purpose database. Because remember, real-time apps have some of these qualities of analytics. They want to run analytical queries, and they have qualities of an operational system that wants to be lower latency and stay online. And you can see some of the media companies up here, Comcast, Hulu, Disney. They want to do personalization over the kind of live stream of data, what you're watching, what you have watched, what you've seen, which other things you've maybe watched quickly and didn't continue. And they want to pop up recommendations to you. And Uber is very similar. It's also popping up recommendations based on geospatial data of where you've been in the past and where you're going today. So these early customers really pushed us in this direction. And over the last 10 years, we've built lots of capabilities into the product to satisfy these customers. And to make this more concrete, I think there's 5 key areas of the product that we've built things that are great for real-time apps. Today, I'm only going to talk about one of them, and that's kind of universal storage or flexible indexing. There's a blog post that's kind of linked at the bottom there that'll go into detail on all of these areas, but today we're going to focus just on flexible indexing. So what does that look like? Well, or why is that important for real-time apps? Well, as we said earlier, we want to drive down the latency of our queries. And there's not a lot of magic to that when it comes to a database. That means your database needs to query less data to answer the query. It can't scan lots of rows to answer a query. And so how that works in SingleStore is we have a storage design that has the fast scan performance of a column store. So that's what's going to be in your classic data warehouse, your Redshift, your BigQuery. And on top of that gives you the point read and write performance of a row store. This is like your Postgres, your MySQL. And what this ends up looking like is on the right of the slide there. It's called a log structured merge tree. And I'm not going to describe it in too much detail. It's a layered data structure. The top layer is in memory, and the bottom layer is kind of immutable ordered files. There's a link at the bottom to a paper. It's a very recent paper from a few weeks ago even, and that was released and published in SIGMOD, which is kind of the premier database conference for database practitioners and researchers, that describes really how this works. But today, I'm just going to show some of the capabilities and show what it can do as opposed to describe kind of the exact layout of the bytes on the files. So the first thing it can do is give you the premier scan performance of a column store. So in this kind of simple example, we have a trades table with 57 billion rows in it, and we're going to find the top 10 most traded stocks. And we can do that, and you can see on the right there, in 5 milliseconds. And if you kind of extrapolate that out, that's equivalent to scanning 1.3 trillion rows a second. So this is very fast scan performance of a data warehouse, of a column store. The blog post that's linked at the bottom goes into a lot more details about how this works, if you're interested. But this is just kind of a proof point that, hey, the analytical capabilities of SingleStore are best in class. On top of this, let's say we wanted to find the top 10 most traded stocks for a single customer, that we add that customer ID filter. In SingleStore, we can put an index on that customer ID column, and we can speed this query up by 10x with that index. Now, on your data warehouse, on your Redshift, on your BigQuery, you don't have indexes. You don't have this capability. You don't really have the option of driving down your latency. Of course, your operational system, your Postgres, has indexes, but they don't have that fast scan performance we just showed on the previous slide. So this is kind of you can see how the data layout is more flexible in SingleStore, so you can kind of to get both of these capabilities, the low latency reads and your fast scans. Now, on top of this, we also have unique keys on top of the column store. And what this lets you do is insert rows, and if you hit a duplicate key error, there's that on duplicate key update clause there, and that lets you update the row. It's kind of an upsert, and if you're familiar with MySQL terminology. And this is very, very rare for a column store. Almost always, if you're inserting into a column store and you want to deduplicate, you have to use another system, another database to deduplicate, and then batch load. But this primary key support lets you just stream directly into SingleStore. And if there's a duplicate, you can deal with it as you're inserting. And again, there's a blog post linked at the bottom there that goes into a lot of detail about universal storage. But as kind of a proof point, since there isn't an industry standard benchmark for real-time applications, we wanted to kind of prove that prove to folks that we can do what we say. We ran 2 industry standard benchmarks, so TPC-H and TPC-C. Now, H is an analytics benchmark, so it's 1 terabyte of data, and it's complex query shapes. And so you can see that orange-yellow bar for SingleStoreDB. We compared against 3 other systems, 2 cloud data warehouses and an operational database. And you can see the yellow bar for the cloud data warehouses. It's the same as SingleStoreDB. We can match kind of the premier cloud data warehouses on this difficult analytics benchmark. You can see the operational database did very poorly on this. And so when I say operational database, I mean like a Postgres, MySQL, SQL Server, something isn't designed for analytics. And it didn't fail to run the benchmark. It just ran it very slowly. We gave up after 24 hours. This particular operational database doesn't have a column store. It's not designed for analytics, so it couldn't do it very well. Now, if you look at the blue bar, that's TPC-C. And so that's an operational benchmark. So that's a much smaller data set, maybe 50 gigs of data, lots of point read and write queries, very high throughput. Now, the cloud database on the far right did very well with this workload. It was designed for this workload. SingleStoreDB also did well on this workload. The cloud data warehouses in the middle, you see they have 0 because they just do not have the features to run this workload. They can't run it. Their workload requires primary keys. It requires strong transactions. It requires point updates and deletes, which some column stores don't support. Others support them very poorly. So this is kind of a proof point that SingleStoreDB can run mixed workloads. It can run transactions. It can run analytics. And that's kind of a requirement for real-time apps that want to combine these analytical queries with kind of lower latency kind of inserts and also lower latency kind of query performance. So hopefully that provides some context on why SingleStoreDB is great for real-time apps. some of the features we have, and pointed to many blog posts with more details that folks can follow up with offline.